Right, let's have a look at some velocity time graphs. Now, as we said before, the gradient of a velocity time graph represents acceleration. Now, you need to be able to calculate acceleration from the gradient of a velocity time graph. And you also need to be able to calculate the distance travelled from a velocity time graph. So let's have a look at these two lines then. If you look at the pink line, you can work out the velocity and you can work out the time. So have a go at calculating the acceleration from the pink line. And then the red line, what's happening there? You've got the increase in gradient going up, then you've got a steady line, and then you've got the line coming back down again. So see if you can work out what's happening with the red line. So looking at the pink line then, it's a straight line. So the velocity for this line is increasing steadily. In other words, it's accelerating at a constant rate. Now its acceleration is the change in velocity in meters per second divided by the time taken for the change in seconds. So from time 0 to time 60 seconds, its change in velocity is from 0 to 120 meters per second. Now remember that equation. Acceleration A equals v minus u divided by t. Remember, v is final velocity, u is initial velocity, and t is the time taken. So the acceleration, the final velocity is 120 meters per second. The initial velocity is 0 because it started from 0, it started from a standstill. And the time taken for this change was 60 seconds. So it's 120 minus 0 divided by 60. So that works out to 2 meters per second squared. Remember, acceleration is given in meters per second squared. Now just remember, you can put that into a triangle. The change in velocity, that's final minus initial, goes at the top. Acceleration and time taken are at the bottom. So cover up the one you're looking for, and the position of the other two tells you which calculation to carry out. So what about the red line then? Now the velocity for this line increases for the first 20 seconds, then it remains constant for 40 seconds, before reducing for 40 seconds. Now remember, velocity is speed in a given direction. So this shows us that the object is moving away from the start point, then remaining at a constant distance from the start point, and then it's coming back towards the start point. Speed-wise, this object is actually accelerating, then cruising at a steady speed, and then slowing down and stopping. So the acceleration for the first part, final minus initial velocity, 80 minus 0, divided by 20 seconds, gives us an acceleration of 4 meters per second squared. For the second part, now the acceleration, the final velocity and the initial velocity are both 80. So it's 80 minus 80, which is 0. So that's 0 meters per second squared. It's not accelerating, it's cruising at a steady speed. And for the third part, the acceleration is 0, the final velocity is 0 because it stops, minus the initial velocity, which is 80, and it took 40 seconds to do that. So it's 80 divided by 40, but remember it's got a negative sign in front of it, so its acceleration is minus 2 meters per second squared. Now another thing you need to be able to do is to calculate the distance travelled by a vehicle using a velocity time graph. This is one where you have to work out the area underneath the line. So we can work out the distance travelled from the area under the line in velocity time graphs, but not in distance time graphs, only in velocity time graphs. So to work out the area, you divide the graph into triangles and rectangles. It'll all make sense. For the triangles, to work out the area, you calculate half times base times height. And for the rectangles, you just calculate base times height. And then you just add them all together. It's easier than it sounds. So you can see from this velocity time graph, I've divided the line into triangles and rectangles. So we've got A, which is a triangle, B, which is a rectangle, and C, which is a triangle. So I just need to work out now what the area is of those triangles and that rectangle. So using the axes, for area A, the base is 20, that's going to be seconds, but it's 20, and it goes up on the velocity axis to 80, so that's 20 times 80, but you've got to half it because it's a triangle. For area B, the base is 40. If you look at the x-axis, it starts at 20 and it goes up to 60, so the base is 40, and the height is 80, so it's 40 times 80. And for area C, it starts at 60 seconds and it goes up to 100, so the base is 40 seconds and it goes up to 80 again, so it's half times 40 times 80. So you add up all of those together and you end up with 5,600 meters.